We are taking example 3. This one says a bacteria culture starts with 740 bacteria and grows at a rate proportional to its size. After 4 hours, there will be 2,960 bacteria. So we need to find the population model. Then we'll see what is the size of the population after 9 hours. And then finally, we'll see that how long it will take to reach the population to 2,570. So first of all, look at the question. It says bacteria size. So let me call size of the population is P. Okay. And then the rate of change of the population is dp dt. Now they are saying that dp dt is proportional to its size, right? And from the proportionality, you can take a constant. You will say that this one is dp dt that equals k times p. So k is the proportionality constant. Now this is a differential equation, and we have some condition that when t is 0, the size of the bacteria is 740. And then after 4 hours, that means p at t equals 4 will be 2,960. These are the conditions given. So we need to find what is our population size, p equals pt. So that we are looking for. So first of all, right here, dp dt equals kp. So we'll do the separation of variables, and the substitution looks like this, that you write dp over p equals k dt. Now take the integral. Okay, so when you take the integral in this case, you are getting natural log of p equals kt plus a constant, right? And we know that p is the population, so it is positive. You can ignore the absolute value sign. Then you can say natural log of p equals kt plus c. So then p must be e to the kt plus c, which is same as e to the kt times e to the c, and we'll write e to the c as a new constant c. That gives me e to the kt. So we got our model with some unknowns. Now we'll determine those unknown values. So rewrite your question or the solution. pt is now c e to the kt. Now we'll be using the initial condition. P0 is 740. That gives me c e to the 0 because t is 0. So that gives you c. So you got c. So then my model look like this now. pt equals 740 e to the kt. Now we need to determine what is k. So we'll be using the second condition. So then you can write here 2,960 will be equals 740 e to the k, and t equals 4, right? So from both sides you can divide by 740. You can cancel 1 0 in here. So you are getting 296 over 74. That is equals e to the 4k. Now if you take the natural log on both sides, you will get 4k equals natural log of 296 over 74. So then k is 1/4 natural log 296 over 74. Now you can grab a calculator and simplify. You'll see that your answer will come out like 0.346574 approximately. So we got our k also. So finally I can use my model now. pt equals 740 e to the 0.346574 t. So this is the population model. Next part is asking what is the size of the population after 9 hours. So after 9 hours, meaning is t equals 9. So then P9 will be 740, and then e to the 0.346574 times 9. Then you can grab a calculator again, and your answer will come out like 16744.4. I'm rounding to 1 decimal place. Okay, let's look at all the solutions in the calculator. So first I'm finding K. So you have 1 divided by 4. Then you have natural log 296. I'm sorry, this is 5, so I have 6. 296 divided by what it was, 74, right? 74. Hit enter. So that is giving you here, you see that 0.346574 approximately. All right. So now I'm looking at this value here. So you can write again 740, and then you take e to the is this one 0.346574 multiplied by 9 and close the parenthesis, hit enter. So you see that 16744.35032. So when you round it to 1 decimal place, that gives me 0.4. All right, this is done. Then the next part they're asking that how long will it take for the population to reach 2570. So that means our PT equals 2570. That will be equals 740 e to the 0.346574 t. Now again you can cancel this 0 from both sides, divide by 74, so it will cancel out here. If you take the natural log, you will get 0.346574 t will be equals natural log 257 over 74, and that tells you t will be equals natural log of 257 over 74 divided by 0.346574. So then I'm taking natural log, and then I have 257 divided by 74 divided by 0.346574, and then enter. So that gives you 3.59233. So I can say approximately I got 3.59.